In the prior video, I went into detail about using these applications. Let's look at some of the communication bus and how it can be added on. So inside of Polycephaly, you've got your communications directory. And then inside of here, right now, there's just a messenger, which is the internal part, and there's socket file. And so the communication system is actually modular as well. So for example, today I'll start adding in MQTT. On the socket file side, you've got client, common, and server. Common is the parts that are shared by server and client. And then client and server are this part, this communications part, is what you would wrap and use in your own application if you did not want to make a polycephaly based application. So for example, if you're making a GUI in Kivy, then you'd be able to import this without screwing up the workflow of how Kivy operates. So let's see, then down here, internal processes. Right now there's just socket file, but these are if you want to build an application and you want your processes to inherit what some of the setup is, but without having to mess around with too much, then this would be the way to do it. So there's just two parts for server and two parts for client. So this is, for example, what server looks like. And then it's pulling from common and pulling from events. This is what common looks like. And then it's got callbacks, and then it's also pulling from like core process definitions. And then right there is just the callbacks. Whereas here you've got just events. So this is set up for server, and then this is some kind of story for client for pulling from common and pulling from events. So the only thing that changes actually is that line right there. So, and then event for clients, same kind of story, where you've got a lot of callbacks being registered, sorry, and then same kind of deal here, callbacks being registered. So for this application, for the client application of Unix domain socket files, we've got client and we've got client and we've got main. And so on the main side, this is the blocking event where you see the menu. And then you've got right there your setup, a couple of variables, server path, reconnect time, signal alarm. And then you've got callbacks. These are just on the internal Polycephaly message bus. So you've got like fall through. We actually don't even need this anymore. And then you've got client notify, and then you've got just a null filter. So there's really not a whole lot that's happening on the internal callbacks. It's basically just receiving messages about disconnected and connected. And then that's where it sits there and sets the internal path. So the main process is able to track it for what you would see up here. Same with the refresh time. So if we pull up a server, these are both Polycephaly based applications. Let's connect. Okay. Hi from the client. Hi from the server. Okay. Server receive message from client 19. Hi from the client. Hi from the server. And then hello from the server. Your client address is 19. Hello from the server. Your client address is 19. This kind of looks like a bug I need to fix with connects not showing up. And then Let's see, we've got reconnect time still there. Okay, so what we're getting to is there's the path, there's the reconnect time, and that kind of information is coming from this. And then inside of the main process being set up, this is actually where it queries and asks for a reconnect time. So that's actually where it's querying the client process and is simply asking what the reconnect time is. And it's going to wait for 5 seconds to get a return, and then it will set that return. So that's internal messaging between processes, threads, forked processes, things like that. Let's see, then it's actually going to connect. So the menu is just driving behind the scenes. The client is actually what's doing the work. So it's telling the client to activate, and then all it's doing is waiting to see if a response came through indicating that yes, everything is ready to go. And if so, or if not, it's going to sit there and show it right there, is a debug message. Then the looping part of the process is really, there's not much. It just keeps going back to the main menu. So you go through your events in the menu, your menu tree, and then it'll return back to the main menu when you knock out like messaging or updating a reconnect or whatever else. These callbacks, how it renames right there, that's actually because since the main thread is blocking waiting for input for the menu, it has to move the messenger over to the side into its own thread, which is what this is about. And that's to sit there and be able to still receive shutdown messages while it's blocking. So an example, here it is. Let's look for a Python process. Okay, got a bit going on. Okay, there we are right there. So we're going to kill. And there you are. So that's how it actually receives sig terms and does graceful shutdown. And then so the thread where it receives these communications, that's what the messaging is about behind the scenes, and that's why we move messaging to its own thread. Okay, let's see what else. So we did callback, we did events. Not a whole lot to look at here. Already kind of went through that, but these are how it's all broken out: callback events, menus, methods, threads, and then core process definition. Then we've got our own variables right here. So menus, kind of as the name implies, these are using a Python module called Inquirer, is how it sits there and does just this really simplified menu input. And so, for example, running this, reconnect time. Okay, let's go look at menu reconnect time. Okay, right there. Well, let's see actually how we even connected. So this is the main menu right there. There's an option, and then it's passed into the actual method reference. And then these are actually a little bit of monkey patching going on here for prompt. This is actually where I hijack Inquirer's prompt, do a couple of extra things, and then Polycephaly method called menu runner is actually what's figuring out some of the stuff behind the scenes to make it all seamless. So reconnect time, menu reconnect time, and then we bounce from that to here, and then we ask for input, and then when we receive that input, we send it to the client thread, and then we wait for a response, and then that's what we set it to. So just an example of messaging happening. Let's see. Methods. yeah, probably gonna delete this file if I don't end up adding anything into it. Threads, you've got a thread that looks for interrupts to happen for the menu, so it can shut the menu down using signaling. And then this is what I was talking about with changing over the messaging thread. So messages will continue to be checked and skirt by the blocking event of menu input. Okay, so let's look at the client side now that the menu side. Client, not a whole lot going on here. This is actually how we store the messages. So when you see, okay, right there, hello from the server, the client address is 19. So that's actually being stored here. Total queue size of 50. And then anything that comes in, say 51 messages come in, then the first message is bumped off of the queue. And then we've got events. So this is more of an example than anything else, not required, just to fill in examples to show people how they can modify even the callbacks, like the process starting, started, stopping, stopped, e-break, if an e-break event happens, connecting, connected, message, disconnecting, and disconnected. So same kind of story as the server. So right there. And then you actually get to see this used over here where these callbacks are actually registered. These are the real callbacks. So then let's see, back on the client side. Sorry. Back on the client side, all it's doing, we start with a reconnect time of 3. Then we are sitting there saying callback event, mailman socket file. So this is a thread dedicated to checking messages from the socket file. And this would be the same thing if this was MQTT or XMPP or SIP or Twitter or whatever else. And then, so it's just going, it's checking to see if anything came through, and then adds it, if there is a message that came through, it adds it to that queue right here, message ingress. And then for shutting down on the client side, what we're doing is sending an end of transmission message, which is the hexadecimal code right here, x04, sending it as a bytes object. And then that's what we send to the server, just to let it know that we're done on our side. And then cleanup. This is where on the client side we just go through any events relating to socket file that need to be stopped. And then birth is super birth is how we inherit from the parent for setting up socket file. And again, it's coming from let's see, on the client side, it would be coming from this. So this is actually what the parent birth looks like, and that's what this right here is running. And then it's setting up your Unix domain socket file object. You're registering callbacks, even registering a callback for mailman socket file right there. So that's how this is called, either here or inside of live on the child. And then death, not really much going on, just kind of issuing a UDS stop. On the client side, it's a little simpler than the server side. Okay, then callbacks. Now this is the interesting part of how buses are, messaging buses are managed. So we've got internal, polycephaly process to polycephaly process, and then we've got socket file. So on the process to process, this is the main thread telling this client child thread that, or I shouldn't say child, but maybe peer thread. These are like activate, reconnect time, send message, list inbox, get message, and delete message. So this is just being remote controlled by the menu, when behind the scenes it's this messaging that's doing it. And then you can use decoration to add filters. So for these callbacks, and then each callback is defined just by itself as its own class, and then message. And so this is what's happening behind the scenes to sit there and put it all together. So even when reconnect time is queried, or if it's changed, then either way it's going to sit there and try and reply with what it's been changed to. So, or what it already is. And then all we're looking for is subjects. So we're not really doing much exotic filtering here. And mostly it's subjects that we're going after. In fact, all of these are subject. Socket file, same kind of premise, but the beginning part, the first argument is actually where we specify our bus. So we say socket file, all the way through we're going to say socket file. And that's how we sit there and say what our message bus is, which is different from our internal bus. And then, and you can create any kind of bus that you want. And so we've sat there and said what bus we're going to watch on. And we've got our fall through right here. We've got right here is where we're looking for callback events like starting and stopping, start dead, stopped, things like that. And then all we're saying is just giving an update on events as a debug message. Right here, same kind of story, disconnecting, disconnected. And so this is where we're actually saying like, okay, well, if it connected or if it's disconnected, then we're going to update the main process to let it know what the path is. And then if it's disconnected, then we're also just going to turn off our reconnect time. And could be a bad idea. I might want to consider disabling this, come to think about it. Like, if we've got this, I think it'll probably knock the, let's see what happens. So we exited the server. Okay. Gonna so it did reconnect. How interesting. So not really sure what was I thinking here. Oh, I see. Okay, got it. Never mind. I'm just not. I need more coffee. Okay, sorry. I had mixed this up. Okay, so anyways, moving on. Let's see. So then this is when a message comes through on the socket file side. So these are all callback events. And then we have our little notice here. And then if it's a XO4, then server has a end of transmission. If we're looking at a stripped, an empty message here, then there's no reason to add that into the queue. And then here we are looking at actually appending onto the queue. And so this is how everything's happening behind the scenes. So pretty simple, kind of a long-winded explanation. I apologize for that. But yeah, that's what's happening behind the scenes, and that's kind of same story for making the server as well. So you've got the main, and then you've got server, and then you've got your events, not doing a whole lot. And then you've got two message buses, again, internal. So we've got client, send to client, kick client. And then we've got socket file. And then these are also handling the different callbacks again. So starting, started, stopping, stopped, disconnecting, disconnected. And then that's actually right there where we send our little default message to the client saying what they are. And then down here is where we just simply echo. So same kind of story. Socket file is the bus, and then trigger event is message. And then we're just sitting there looking like for XO4, what I showed earlier on client sending it when it's disconnecting. And then if the client did send a message through, then we're going to sit there and just echo it back. So we'll say server received a message from client, and then go and send that message right back to them. So that's about it. Pretty simple.